overriding? Yeah. No? Yeah. Inner class. You mean the child class, I believe, right? Yeah. So we said in inheritance you have a parent class, a superclass, and a child class subclass. Then we said it's possible to define a method using exactly the same name, but also the same number of input parameters. It has exactly what we call same signature, right? In the child and in the parent. What's going to happen if you create an object of the child is going to override this method in the parent. It's like hiding it, right? But if you define an object of the parent, what's going to happen? Which method is going to be executed? The parent one, right? Another question. Inside the child itself, is there a way to access the parent method? We also discussed this. Can someone remind me what should I do to access the parent method in the child? Assume now we have two methods, exactly the same name, one at the child, one at the parent, but I want to access the parent one at the child. Yeah, use the super reserved word, right? Super dot method is going to give you the method at the parent. Good? This generally has a concept in object-oriented programming that is called dynamic binding, right? And this is one of the hard things about object-oriented programming is there are many conceptual things. So you need first, before writing any code, to understand the concept before jumping and write something. Good? We already discussed overriding these things, but the general concept is dynamic binding. What do we mean by this? Now, given the case we discussed last time, which is a parent, child, you have two methods, the same name, the same thing, and like method overriding. During runtime, you don't really know, or the compiler doesn't really know which method is going to be called, because it depends on the object you create, right? It depends on if you create an object of the parent, then it's going to be the parent one. If you create an object of the child, then you do the overriding, and then you're going to call the method of the child, right? That means now you have a runtime dependency on which you created and which classes you reference, right? This is called dynamic binding because you bind, if you have the same method, multiple names, you bind yourself to a certain method based on a runtime information, right? This is the general concept of dynamic binding. Okay, so one example here is we have a subclass that we call a subclass or a child class that we call my sub, and it extends a superclass that we call my super. And then I create an object like this. My super ref equal new my sub. What do I do here? It seems to be a mess, right? What do I do here? Can someone explain to me in clean statement, clean wording, what does this line do? For a bonus mark as well. No? Yeah? This line has nothing to do at all with the reserved word super, because it's my super, right? So, yeah. No, and that's not correct. Here's what we do, right? And you should have known this from previous lectures. So this is not a new information. First of all, new my sub. My sub is my subclass, right? So I told you before, new is a reserved word to create an object in memory, right? So by just using this right side, new my sub, I create an object in the memory of type my subclass, right? This is what does these two things do. And then I create a reference to this, as if I'm creating a pointer to this, of type my super. Would this be allowed? What did we call this last time? It's similar to a concept that we discussed before. It's typecasting, right? you cast a child class to a parent class. Why this is allowed? Because your parent is as if it's the wider thing, and then it's okay to take a child object and then make a parent object referring to it. This makes sense? So now what we do is we create an object in the memory of type mySub, which is a child class, and then make a reference to it of the type parent, which is allowed. I gave you last lecture the example of double x equal 10, where 10 is an int. This is allowed. Or also say int x and then double y equal x, right? Double y equal x, x is int, y is double, but this is allowed because you do a casting, right? Double is the wider type. So what we do here is we create an object of the child and we make a reference to it of the type parent, right? Now the problem comes of we put this together, but do you have a question? Because if you don't understand this, then what is coming is a disaster. So make sure if you have any problem, ask, right? So you know now what you are doing? Yeah? Yeah, good. That's correct. Then what do we do? Do you remember from last lecture? If you are making, so your friend here is asking a very interesting question that we discussed also last time. You are creating an object of type child, and you are making a parent pointing into it. But generally, a child can have more methods and members than the parent. What happens? Is what we call here superref, which is the variable of type parent, is able to access those extra methods or not? This was your question, right? What do you think? No, right? Because the type of superref is a parent one, so it does not have access to the child methods and members. Good? Right? So this was a good point. The other point is, now what if we have a method overriding? So what if we have a method that is inside my sub and exactly the same name inside my super? What would happen if it's called an instance method, for example? Now we did a method overriding. We have an instance method at the child, an instance method at the parent. What would happen? It's already written here. But what do you think is going to happen? Yeah? No. And this is the trick, right? And this is one of the trickiest things in object-oriented programming. So the method that is being called is the method of the object type, not the reference type. Right? And this is dynamic binding thing, right? So what's going to happen here if you reference super.instance method, you are going to reference the one at the child, not the one at the parent. It's very confusing, right? Yeah. Yeah, but you don't directly access them, so that's okay. You know what? This is similar to, you have access to setters and getters because they are public, but internally setters and getters have access to the private members that you don't have access to. So it's still at the interface, right? So take it as a rule. The method that you call, in case of overriding, is the method of the object type, not the reference type, right? Later we will see a case where what you said will happen, but for now it's as it is. Good? So we are going to call the sub method, not the parent method. Good? So let's take an example. So here I have a class that I call my super that has a method that is called toString, and then it prints my super. Now I have another method, another class that is my sub. It has another method that is called toString my sub, and then I write some test to test these things. So honestly speaking, my intention was to give you this, but this should take a couple of minutes, but I know if I give it to you to write, you will take until the end of the lecture. So let's just discuss it, right? And make sure if you guys have any question, let me know. So first of all, I create multiple objects. And here comes the thing. If you understand this example, then you understand what we want to say today. Good? I create a reference of type my sub, and it points to an object of type my sub as well. So this is an easy one, right? B is of type my sub, pointing to an object of my sub. It's the straightforward object instantiation. And then I create another reference that I call Q. It's of type my super, and it points to B. What does this line do here? We have seen this before multiple times. Yeah? Yeah, it makes Q point to the object that is also pointed to by B, right? And then I create a third reference that is called R, and then R is of type my super, and then my super, so this is a straightforward one, right? So the one that is mixing both is the one that is Q, because it's of type my super, but it points to my sub. The other two are just the straightforward ones. So let's focus first at B and R, because these are the simple ones. When I say system.out brain line B.toString, what do you expect to see? B is of type my sub, which is the sub one, right? So you will see my sub. What about R? R also is a straightforward one. R is of type my super, right? And then when you print this, you will call this method and you will see my super. What about Q? Q is the confusing one. But based on what we said in the last slide, what do you expect to see? What do you think? Yeah? My super. And this is because? Yeah, so let me repeat a statement that I just said like a couple of minutes ago and let me know if you still say the same thing, right? What I said is, if you have an object of type parent pointing to an object, if you have a reference of type parent pointing to an object of type child, and in case of method overriding, the method that you call is the method of the object, not the reference. What is the object type here? My sub. So which one should we call then? My sub, right? Do you now understand what do you mean by this, right? So in this case, you will see my sub, and then my super is for the super one, which is R. Yeah. You can look into this like this, but the problem is, what if I call a method that exists in the child but does not exist in the parent? You are not allowed to do this for Q, because Q is of type my super, so it does not have access to the child. So if you just keep it open as you said, it's not correct. It's correct just in this case, right? Good? Is there any question? Okay. So this dynamic binding thing is actually part of a bigger concept in object-oriented programming that is called polymorphism. What does polymorphism mean? Generally, it means multiple forms. Right now, a method can take multiple forms at runtime based on what reference and what object you are accessing, right? So this concept is great, and we will see, we'll have some examples on this that will explain to you what do you mean by this. One example here, and we will conclude by this, is assume we want to create a class that we call graphic object, right? And this is, in fact, how things are implemented in like graphical applications. If you draw Inkscape or something, Paint or something of that sort, you cannot create a class for each object alone because they share some information, right? And here comes the inheritance. You have objects that share some features, but each one of them will have its own features as well. So what you do is you create a parent class that share all the basic features, but then internally for each certain, in this case, graphic type or graphic shape, it will have its own features, right? So all of these are supposed to be childs. If you have a question, ask, right? Okay, so all of these are childs of the type graphic object. We create a class that we call graphic object. It's our super parent class, and all these four, one is a point, one is just rectangle, and then triangle, and then circle. All of them are childs of the parent class, which here we are using the extends reserved word for inheritance. Good? So let's see how polymorphism works. What we want to do is we want to create a method that is called area. This method will calculate for us the area of the current object. right? The problem is if we implement area in the parent, the area has a different equation for each shape, right? For circle, it's like by r square. For rectangle, it's x multiplied by y. So we have different things, right? So that means area has to be specific for each type, right? This makes sense? Good. So the way we do this is we create an area template, and later we will extend this, but for now we'll create an area template in the parent class. And then inside the child class, you will have your own implementation for the area method, right? And then, for example, for the point, you don't have any area, so the area may be 0. For rectangle, you have x, y, and then triangle, you have, I don't know how you calculate the area of a triangle, and then I'm too old for that. And then for a circle, it's by r square, right? So let's see how we do this. And then we want to write a test program. We want to write a test program that instantiates, let's say, array of 100 objects. And then during time, I call the correct area method based on the type of the object that I'm calling right now. And here comes the magic of polymorphism. You have one method that is called area, but it has different implementations based on the class that you are calling, right? So let's see how these things work. So first of all, I create a count of 100 because I want to create an array of 100 objects. What do I do in this line? I create an array of objects. All of them are of the type graphic object. And then they have 100. I create a for loop. And then, because we have 5 types of graphics, I'm going to take every 5 of them. So like 100, that means every like 20 will be point, 20 will be rectangle, 20 will be circle, 20 will be triangle, right? This is what we do in this loop. And then we create these objects like 5i, like for example 0 will be a point, 1 will be rectangle, 2 will be triangle, and 3, 4, and then 5 will be point again, etc., etc., etc. Right? Then right now, if we have a method that is called area, so I write a method in our test that I call largest area. What does this method do? It calculates the area of all the objects in my 100 list, and it returns the largest one, right? So it even compares them, right? How I implement this largest area thing? I take as an input a graphic object, and then I start doing things. So the area is initially 0, and this is an index for the maximum one. Then I go through my list one by one, and then I call gi.area. Here comes the interesting part. Do I know what is gi? Right? Gi is known at runtime. For example, if I is a 0, that means gi is of type point. But if I is 1, g1 is of type triangle, right? So here gi has a different child type based on what you initialize them in the previous slide here, right? And then it's okay to use exactly the same line of code to calculate the area for all the objects, right? And then later you compare them and then you take the max, right? So you should try this at home, and then maybe next time I'll ask you about it. Thank you.